All right, now we're going to determine the 6 trigonometric ratios. Wait, what? Six trigonometric ratios. Yeah, that's right. They're complicating that too. Used to be sine, cosine, tan. Now it's sine, cos, tan, secant, cosecant, and cotan. Notice how there's a bunch of cos in there? You'll find that they pair up, but there's only ever one co in a pair. I'll show you. So this is kind of not the greatest one to try working on because it's not necessarily in tangent 1 or quadrant 1, but we can get there. Remember though that I told you that y is sine and cos is x, and so we can kind of figure that out. Let's just make a little note here. Y is actually the opposite side because it's always going to be opposite of the angle. And x is always going to be the adjacent side because it's always going to be adjacent to the angle because the angle is always from x to the terminal arm. So if we know that, then we can go through and figure out all of our ratios. Now, remembering also that the terminal arm itself is 1. So 1 is the hypotenuse. All right, so those are our basic values, and we can start determining the individual sine ratios that way. So I'll write them over here. Sine of theta is going to be equal to sine is opposite over hypotenuse, so it's y over 1, so it's just going to be y. But we can write it y over r, just in case r, the radius, isn't 1, we can just keep track of it that way. All right. Next, we have cos of theta. Remember that that's adjacent over hypotenuse. So I guess I'll write 1, whoops, that's kind of some kind of weird hybrid, or r there, just in case it isn't 1. Sometimes they'll give us like word problems where it's not 1. All right, back to cos. Cos is adjacent over hypotenuse, so it's going to be x over r. And finally, tangent is opposite over adjacent. Opposite over adjacent is y over x. Now, if I were you, I'd be writing these down somewhere handy. Now, what they do for the other 3 trigonometric ratios is they switch them, they turn them upside down. So sine, for example, needs a co because it doesn't have one. So we're going to use cosecant for the reverse of sine. So we call that cosecant CSC theta, and it's going to be r over y. Just flip it upside down. And cos already has a co, so we're just going to call it its reciprocal secant theta, and it's going to be r over x. Now remember that r is often 1, so it's just going to be 1 over x. Last one, cotan. Since it doesn't have a co, now it does. Its buddy is cotan theta, sorry about the pen, which is x over y. So now we have 1, 2, 3, 4, 5, 6 trigonometric ratios. Now, back to the question that we're looking at here. They gave us 510 degrees to deal with. 510 is obviously bigger than 360, so we've gone a full rotation plus a little bit. And if we wanted to do the math, we could go 510 minus 360, and we would end up with, we did this last time, 150 degrees. So this one is just 150 degrees, which means that this part underneath is 30 degrees because it's 150 less of the full 180. So my reference angle is 30 degrees. That worked a little better.